Hello everyone, myself Dr. Santami Kundu. I welcome you all to this lecture of soft computing techniques. This is the third lecture of module 9. So till now we have covered the introduction of rough set theory. We also learned indiscernibility relations. So today we'll try to understand the lower and upper approximations in rough set theory. So, in rough set theory, the concept of approximations is used to handle uncertainty and vagueness by dividing a set into two parts, that is, lower approximations and upper approximations. These approximations depend on the indiscernibility relations, which partitions the universe of objects based on their similarity. So, the lower approximation of set X consists of the objects that are certainly in X. In other words, it is the set of objects whose equivalence classes, that is group of objects that are indistinguishable based on the given attributes, are completely contained in X. So if the equivalence class you can write that is just like XB, so XB is completely subset of the target set X. Upper approximations. The upper approximations of a set X consist of the objects that are possibly in X. This is the set of objects whose equivalence classes intersect with S. I mean the equivalence class XB and X, this is not equal to null set. So meaning that the class of an object might have elements in X, but we cannot be sure the elements of the class belongs to X. So we can write the definitions. Let this is information table. UA U is the set of objects are the attributes, and B is a subset of attributes, and X is the target set which is subset of objects. We can approximate X using only the information contained in B by constructing the B lower and B upper approximations of X, denoted as B lower hyphen X. So that is the lower approximations, and B upper X, this is the upper approximations. So denoted is that where B bar B lower X is the set of elements which is contained in the target set X. So you can write here B lower X. So B lower approximation X is the set of elements which are completely contained in the target set X. Whereas the B upper X, you can write like that. This is the set of all objects whose equivalence class and the target set is not equal to the null set. So lower approximations of X is a collection of objects which can be classified with full certainty as a member of set X using attribute set B. So that is B lower hyphen X. So that is the lower approximation. Similarly, for upper approximation, full certainty is not there. This is the possible certainty. This is the possible certainty. So let's check that. So check all these things with an example. So consider a universe of objects, that is U, A, B, C, D, E, and we define an equivalence relation based on an attribute. For simplicity, let's use a single attribute here. So universe here U, so objects are A, B, C, D, E. In disability relations, we will define equivalence classes based on an attribute such as color. The equivalence relations divides the universe into the following equivalence classes. So this is the color. So attribute is B, we are assuming. So objects A, B, C, D, E. So color is red for A, B for red, C for blue, D blue, E green. So you can write indiscriminity of color. You can write here first red, so that is A, then blue C, and then E. So this is indistinguishable color. So now here the equivalence class for A is AB. This is for red. For C here CD. So there are three equivalence class. You can write it equivalence class A, equivalence class C, equivalence class E. Target set we are defining A and C. So we try to find the lower approximation, which is that B lower hyphen A, and upper approximation B upper hyphen A, where A is the target set. So here try to understand this all these things step by step. So step 1, we calculate the lower and upper approximations of A. So lower approximations of A, the lower approximations consist of objects whose equivalence classes are completely contained within A. So remember here A is A and C. So for object A, the equivalence class for object A is AB. Since A contains both A and B, and here the target set is A and C. So which is so there is no certainty in A, as there is C is not present here. So here you can write A is not certainty. Similarly for object B, the equivalence class for object B, that is AB, this equivalence class contain B, but B not belongs to the set target set A, so it is not certainty in A. Similarly, for object C, the equivalence class for object C is CD. Since C contains this third bracket C contains C and D is not belongs to A. Remember here A is the target state, which is A and C. So here D is not there, so C is not certainty in A. Similarly, for equivalence class CD, D is not belongs to A, so that is not certainty. For object E, the equivalence class E does not intersect or does not have common in A, so it is not contained in A. So you can write the lower approximation of A is phi. Lower approximations which is A. So here A color you can write B, so B bar A, that is null set. Target set is A here. Similarly, try to understand the upper approximations of A. The upper approximation consists of objects whose equivalence class intersect with A. Now here the target set A is A and C. So here equivalence class A, that is A and B. So if you intersect between A and this A, you will get A. So they could belongs to A. So A may be in the upper approximation, A will be present there. Okay. Similarly for object B, AB, so intersect is also here is B. So intersect here also A. So the for B class is B, equivalence class for B is B, which is you can write AB. So you can write this A is A. So B also belongs to the set A. For object C, that is C and D. So objects are A, B, C, D, E. Equivalence class for A is AB. For B is AB. For C, CD. For D, CD is the E. So in lower approximation is null set, so no one is present in lower approximations. But in upper approximations, as the set is A equal to A and C, the intersection is here. For A, intersection is A, here also intersection is A, here is C, here is D. So these three are present, as I may write here that this intersection A is this element A, this intersection B intersection A, the element is A, C intersection A, that is C, C intersection A, that is also C, this is D intersection A is C. So this A, B, C, D are present in the upper approximation. So you can write if the color is B, so that is B lower A, this is B upper A. So now summary for lower approximations, identify the set of objects whose equivalence class are entirely contained within the target set A. In this example, the lower approximation is empty because no equivalence class is fully contained within A. Upper approximation identifies the set of objects whose equivalence classes intersect with A. In this example, the upper approximation includes A, B, C, D since the equivalence classes intersect with the target set. These approximations help in handling uncertainty in data, providing a way to model incomplete knowledge and decisions. So try to understand few more examples. So here examples are that suppose we have a universe of the objects A, B, C, D, E and equivalence relation R which divided these objects into equivalent classes. So here you can write the indiscriminate of the relations, whatever the relation is that, attribute is that. So here for attribute is B, you assume. Then here every elements are different. So A, B, C, D, E. This is the indiscriminate. Now target set A is A, C, D. So try to find lower and upper approximations. So target set A, C, D is a subset of U. As you know, that target set must be subset of that. And we want to compute the lower and upper approximations of A using an indiscriminate relation based on these equivalent classes. So that is the equivalent classes. So step by step calculations. So lower approximations of A. So we try to find these things first. So the lower approximation consists of all objects in U whose equivalence classes are fully contained in A. So here the A, we need to write A, which is A, C, D. Now try to understand A, this A fully subset of that. So A, this is equal to A, which is subset of A. So it will entirely contain in A. So A is certainly in A. Similarly, B is not contained in A, so B is not certainly in A. C, A, C, D. So C is certainly contained in A. D also, and E is not. So here in lower approximations will be A, C, D. So that is basically you can write it B bar A. B lower hyphen A. Similarly for the upper approximation, so here the set something like A intersection, this target set A is not equal to null set. So here is A is equal to ACD. So as A there is it is intersection is A, so that might be in A. For B no scope, so for C might be in A, D also, and E no scope. So here upper approximation is ACD. So you can write it B bar A is ACD. So here the conclusion that so lower approximation is also ACD, upper approximation is also ACD. In this particular example, the lower and upper approximations are the same, meaning that we are certain that the object in equivalence classes of ACD belongs to A. We will discuss more on this topic. Now try to understand another example. So we will use a universe U with 5 objects and 2 attributes. The objects will be classified based on the attribute values and will calculate the lower and upper approximations of a target set. So here universe U is, let the universe U is A, B, C, D, E. Attribute values, that is indiscriminate relations, will define equivalence classes based on an indiscriminate relations. So here objects are A, B, C, D, E. Attribute 1 is A, 1, for A is 1, B is 1, C is 1, D is 2, E is 2. Here the attribute, the value of attribute 2 for object A is red, for B blue, for C red, for D is green, for E is blue. So here if I write the attribute relations, I am writing it A1. So you can write for attribute 1, I am writing it A1. So that is basically A, B, C and D, E. Because here everything is 1, 1, 1. So this are so these 1, 1 are indistinguishable. These are indistinguishable. Similarly here if you write indistinguishable relations of 2 attribute 2, so you can write it AC, then blue, so BE and D is there. So this is of attribute 1. Now with the base of target set 1, we'll try to find the uh, lower and upper approximations, and you try to find the lower and upper approximation of on the basis of attribute 2. So right now we are trying to find the target set is that, so we try to find that A1 hyphen A and A1 lower approximations with respect to attribute to A1 and upper approximation with respect to A1. So try to understand these things. Target set is A, C. So define lower and upper approximations. So the lower approximations, the set of all objects whose equivalence classes are entirely contained within A. These objects are certainly in A. In upper approximations, the set of all objects whose equivalence classes intersect with A, these objects are possibly in A. So here again I am writing that equivalence classes, suppose X is the equivalent classes with respect to attribute A1, so that certainly contained in A. Here X attribute, so it A1, this is not the null set. So step 2 will construct the table. So now try to understand step 1. So lower approximations of A, the target set is A, as you know, that is the AC. Target set is A, that is basically AC. So A is not a subset of that. Here A is A, B, C, which is not a subset of AC. So it will not be present. So hence A is not certainty in A. Similarly, B is ABC, so B is also not certainly in A. C is also not certainly in A. Similarly, you can cite D and E also not certainly in A. So here also the lower approximation of A is the null set, so you can write A lower A is the null set. Upper approximations of A for, okay, so object here, the intersect of the target set is not equal to null set. So here A, so target set is AC, so here it is not intersect, so A could belongs to A. Similarly, the equivalence class for B is ABC and the target set A is that, so for B target set here the equivalence class is ABC, target set A is AC, so this intersect is just AC, which is not equal to null set, so B present in the upper approximations. Similarly, C also present in the upper approximations, but D is not present. We can understand this thing with the table. So table is that objects are A, B, C, D, E. Equivalence class for A is ABC, for B is ABC, for C is ABC, and for D it is DE. Here target set A is A and C. So here object is A, B, C, D, E. Equivalence classes for A is ABC, for B is ABC, for C is also ABC, and D is for DE, and for E this is DE. So now the as this A is not entirely contained in the target sets, so A is not present. Similarly, B, C not present, D is also not present. So here A1 lower A, that is the null set. But here the intersection is A and C for A, B, C, so that is present in the upper approximations. Here is intersection is null set, so that is not present. So we can say the lower approximations is phi and upper approximation is ABC. So this shows how lower and upper approximations are derived based on equivalence classes in the context of rough set theory. The lower approximation identifies objects that are certainly in the set, while the upper approximation identifies objects that may be in the set based on the indiscernibility relations. So In the conclusion, I hope you have understood the concept of lower and upper approximations. Lower and upper approximations. So you just try to solve the previous questions. We solve on the basis of attribute O1. So solve the previous questions. I mean solve the last questions with the on the basis of attribute 2. We solve it attribute 1, so we solve attribute 2. So we try to find target set is same. We try to find lower approximations of x, find this and these things. So these are the references of today's class. Thank you.